Question is, what do you understand by pairwise independence of mutual independence of the number of events? Does pairwise independence implies the mutual independence? If A and B are mutual events, probability of A is 1 upon 3 and probability of B is 1 upon 4. Find probability of A union B and probability of A when A union B is already happened. Pairwise independence. Let A and B has been the events associated with the sample space as they are said to be pairwise independent if probability of A intersection AJ is equal to probability of AI into probability of AJ, where I does not equal to J, which is equal to 1 to 1, so on. Now mutual independence. Let A1 and A2 and AN be n events associated with a sample space S. They are said to be mutually independent if the event subset, say A11, A12, AIK, K is less than N of A1, A2, AN have probability of A11 intersection A12 intersection so on intersection AIK bracket close is equal to probability of A11 probability A12 probability AIK. Thus A1, A2, AN are mutual independent if probability of probability bracket starts AI AJ is equal to probability of AI into probability of AJ for all values of I. Does I not equal to AJ 1 to N, and probability P bracket starts AI intersection AJ intersection AK is equal to probability of AI into probability of AJ into probability of AK. I does not equal to J into K is equal to 1 2 so on. Probability of bracket starts A1 intersection A2 intersection AN is equal to probability of A1 into AN, so is equal to probability of A1 into A2 and AN. Thus for mutual independence of A1 A2 AN we get NC2 conditions from equation 1 and NC2 conditions from equation 2 and NCN condition from the last equation. Thus the total number of condition for mutual independence of A1 A2 and are NC2 NC3 plus so on NCN, so which is equal to NC0 plus NC1 plus so on NCN bracket close minus NC0 minus NC1 which is equal to 2 raised to power n minus 1 minus n, because the sum of the binomial coefficient is 2 raised to power n. So pairwise independence does not imply the mutual independence. So the mutual independence imply pairwise independence, but the converse is not necessarily true. Second part, A and B are the independent events, so probability of A is 1.3, probability B of 1.4. So probability of A union B is equal to probability A into probability B minus probability A intersection B. So probability of A intersection B which is equal to